In this video, I'll be going over the 2.2 quiz review covering solving one-step equations. For each of these, we're going to identify the unknown variable, we're going to use inverse operations to solve, and we're going to do a quick mental check to make sure that we got the answer right. I'm going to take a look at number 1. I have h minus 3 equals negative 2. My variable here is h. h minus 3 equals negative 2. In order to get rid of a minus 3, or move it out of the way, I'm going to add 3. Negative 3 plus 3 will give me 0, which is what I want because I want this h to be all by itself. But if I add 3 to the left, I must also add 3 to the right. Negative 2 plus 3 is 1, so h equals 1. I'm going to do a quick mental check to make sure that's correct. If I plugged in 1 for h and I did 1 minus 3, would that equal negative 2? The answer is yes. If you got h minus 1, you are correct. Looking at number 2, I have m minus 8 equals negative 12. My variable here is m, and I'm subtracting 8. In order to get rid of this minus 8, I'm going to add 8 because a negative 8 plus 8 will give me 0, leaving me with just m. If I add 8 on the left, I must also add 8 on the right. Negative 12 plus 8 is a negative 4. If I do a quick mental check and plug in negative 4 for m, I have negative 4 minus 8, which does equal a negative 12. Number 3 says b minus 40 equals negative 40. My variable is b, and I'm subtracting 40. The inverse operation of subtraction is addition, so I'm going to add 40 to both sides. Negative 40 plus 40 gives me 0, leaving me with just b. b is equal to negative 40 plus 40, which you cancels, but then you would get nothing. You want to think through what this actually means. Negative 40 plus 40 is 0, so b equals 0. If we were to plug that in and do a mental check, 0 minus 40 equals negative 40. That is correct. Number 4 says m minus negative 12 equals 10. My variable here is m, but I want to go ahead and simplify these signs. I've got a minus and negative. Anytime you see a minus and negative, you can go ahead and change it to a plus. So this can be reread as m plus 12. In order to get rid of a plus 12, I'm going to subtract 12. 12 minus 12 would give me 0 and leave me with m. But if I subtract 12 on the left, I have to also subtract 12 on the right. 10 minus 12 is negative 2. Number 5 says x plus 12 equals 6. My variable is x. If I'm adding 12, the inverse of adding 12 would be to subtract 12. 12 minus 12 is 0, which is what I want, leaving me with the x. But if I subtract 12 there, I have to also subtract 12 over here. 6 minus 12 is negative 6. Looking at number 6, I have w plus 2 equals negative 13. My variable is w. If I'm adding 2 to w, I'm going to subtract that 2 to get rid of it. 2 minus 2 is 0. And if I subtract 2 on this side, I'll get that w equals negative 15. For number 7, I have negative 17 equals b plus 4. My variable here is b. It's on the right-hand side this time. I have b plus 4. To get rid of the plus 4, I'm going to subtract 4 from this side. 4 minus 4 gives me 0, leaving me with b. If I subtract 4 on the right, I'm going to also subtract 4 on the left. Negative 17 minus 4 gives me a negative 21. Number 8 says k plus negative 9 equals 7. My variable is k, and I like to go ahead and simplify what's going on here so I don't have two operations. Plus a minus is the same thing as subtracting. So if I'm trying to solve for k, and I have a minus 9, I'm going to add 9 to both sides. Negative 9 plus 9 is 0, and 7 plus 9 is 16. Moving on to 9. Moving on to 9, I have 3h equals negative 42. Now we're dealing with different operations. My variable here is h, but 3h means I'm multiplying 3 times h. So in order to get rid of or undo multiplication, I'm going to use division. 3 divided by 3 gives me a 1, and then I still have my h, which can just be written as h. If I have one h, I just have an h. These 3's essentially cancel, which is what I want. But if I divide by 3 on the left, I must also divide by 3 on the right. So negative 42 divided by 3 gives me a negative 14. Number 10 says 8m equals 16. My variable here is m. Once again, if I have 8m, it means I'm multiplying 8 times m. To undo multiplication, I divide. 8 divided by 8 is 1, leaving me with just an m. If I divide by 8 on the left, I'm also going to divide by 8 on the right. 16 divided by 8 is 2. Once again, you can do quick mental checks for these as well. If I were to plug in 2 for m right here, I would have 8 times 2, which does equal 16. Looking at number 11, I have negative 3t equals 51. My variable is t. Once again, I must be multiplying because I have negative 3 times t. In order to undo multiplication, I'm going to divide by a negative 3. I want to get rid of the negative as well. When I divide a negative by a negative, it'll give me just a positive, and then 3 divided by 3 is 1, leaving me with just t. If I divide by negative 3 on the left, I must also divide by a negative 3 on the right. 51 divided by negative 3 gives me a negative 17. Looking at number 12, I have negative 3r equals negative 24. In order to get the r by itself, which is my variable, I'm going to divide by negative 3, just as I did on number 11, because negative 3r means negative 3 times r. To get rid of the negative and the 3, I need to divide by negative 3 on both sides. Then I'm left with r equals 24 divided by 3. Negative 24 divided by negative 3 is 8. Looking at number 13, I have h divided by 3 equals negative 2. Here, I'm dividing h divided by 3. So in order to undo division, I'm going to use the inverse operation of multiplication. If I have a 3 in the denominator, I can get rid of it by multiplying by 3 in the numerator. So 3 over 1, or just 3. These 3's will cancel, leaving me with h over 1, and anything over 1 is itself, so I'm left with h. On the left, I multiplied by 3 over 1, or just 3. So I'm going to multiply by 3 on the right. Negative 2 times 3 is negative 6. You could do a quick mental check. If I plugged in negative 6 for h, I'd have negative 6 over 3, which is negative 2. So this is correct. 14 says I have 1 over 8m equals 6. My variable here is m. And what I'm doing here is I'm multiplying 1 over 8 times m, and that's equal to 6. Well, usually we would divide. If I have multiplication, I'm going to undo it by division. But because we have a fraction, dividing a fraction by a fraction can get really messy, so I want to remember this rule that if I have a fraction I want to get rid of, I can get rid of it by multiplying by its reciprocal, or its flip-flop. So I'll multiply 1 over 8 times 8 over 1. When I do that, the 8 on top cancels with the 8 on bottom, the 1 on top cancels with the 1 on bottom, and I'm left with a plain m. If I multiplied by 8 over 1 on the left, I have to also multiply by 8 over 1, which is the same thing as just 8 on the right. So then I have 6 times 8, which is 48. Number 15, I have 5 equals y divided by 12. My variable is y. In order to get rid of the 12 in the denominator, I'm going to multiply by 12. You could think of it as 12 over 1. These 12s will cancel, leaving me with y. But if I multiply by 12 on the right, I have to also multiply by 12 on the left. 12 times 5 is 60. Finally, I have j divided by 3 equals 2 over 5, or 2/5. Even though this is set equal to a fraction, don't get confused by that. I have j divided by 3. To get rid of the divided by 3, I'm going to multiply by 3. The 3 on top cancels with the 3 on bottom, leaving me with j. And then I multiply by 3 on the right-hand side. If I multiply numerators together, 3 times 2 is 6. And then I divide by 5. 6 actually can't be divided by 5, so I'll just write this as the fraction 6/5.